So hello, everybody, and welcome to today's showcase. So my name is Tim Harrison from IOHK, and this is the second in a series of technical showcases that we're running for the ETC community to look at the 51% tax. So today we've got another development team to showcase a technical solution. So we're joined today by Creepers, Ambroid, Masterdubs, and also this is based on a proposal from Dexaran. So we'll hand over to those guys in a moment, but first just a little bit about how we'll run the call today. So IOHK's development team has already presented its showcase, its proposal. So we'll follow a similar format to that we have. So we'll have around some time to run through the presentation in a moment. There'll also be a session at the end for Q&A. In the Crowdcast app, if you're following along live, you'll see an ask a question section. So please use that to drop your questions in there. There's also an upvoting capability within that. So if you see any questions you feel are particularly pertinent that you haven't asked yourself, please click on that and that will rise to the top so the guys can address those questions first. Now, to be very clear, today is a showcase. It's a technical showcase. We don't want to get into the particular merits, the pros and cons, the whys and wherefores. This is an open opportunity for each developer team to share the engineering approach that they're proposing to take as a response to this ECIP. So any questions you ask, try and focus on the execution rather than too much on things like timelines and as I say, pros and cons of each particular solution. So we won't go into that kind of detail, but we will later in the process for that. If you're watching this on Crowdcast Live, then welcome. If you're watching this after the event, we'll be sharing this on YouTube as well afterwards as well. So please drop any comments or questions in there as well so that people can come back and comment and join the conversation, even if not live.
Hello, I'm Ambroid. I'm an investor and a miner, similar to Creepers. But I'm here from more of a spectator standpoint instead of an ETC community member standpoint. I'm really just watching both Perl and ETC from the sidelines, and I've grown really frustrated with how the 51% attacks on Ethereum Classic have been multiplying really. There were some last year and nothing was done about it. So I just think it's time to step up and show up to one of these presentations. I was asked to be here to maybe help explain what's going on. So I'm passing it off to Masterdubs.
Hi everyone, thank you for attending the meeting. I'm Masterdubs, Julien. We developed the solution PillGuard in PL to counter the 51 attack. So we are here as supporters and to explain that solution the best that we can to help protect the ETC community and mining and cryptocurrency community in general, because it's really important to protect the users if we want the crypto to be adopted widely. Thank you. Ambroid, I let you.
All right, so if you could show the screen I'm sharing, please. Oh wait, you minimized it for me. There we go. Good. So first off, we'll start with the basic explanation of how a typical 51% attack occurs, right? And most of the people here will be familiar with it, but nevertheless, we should go over it just in case someone isn't. So typically, a 51% attack occurs when a miner wants to send coins or tokens to an exchange, sell them, and then act like he hasn't sent the money to the exchange and take both of the stacks, right? So at first, the miner needs to have significant hash power. He needs to mine the blockchain privately, offline. And when he deems that he has mined enough blocks so that he is maybe a tiny bit ahead of the real network, that's when he goes online and proposes that he is now the correct chain. Because in the Nakamoto consensus that is used in Bitcoin and in many other proof of work chains, the longest chain is the correct one. And it doesn't matter whether it is malicious or not, right? So what happened in the meantime when this offline miner mined his own chain? He injected his own transaction into the history, right? He now acts like he hasn't sent money that he has actually sent. So the blockchain rollbacks and money's lost mostly on the exchanges part, because usually these attacks occur by depositing a token into an exchange. So what have exchanges done to mitigate this issue? Well, the only thing they can, they've increased the necessary confirmations for depositing Ethereum Classic. Now it's in the whereabouts of 20 days or so to deposit your Ethereum Classic to an exchange. It makes effective arbitrage between exchanges very painful. It makes depositing money by miners, by investors, by anyone using the tokens to exchanges extremely painful. So the question is, when would this large or huge reorganization far back into the history happen? Normally, it shouldn't happen. It can only, for a legitimate reason, it can only happen in one edge case where a single miner or a mining pool has mined a large amount of blocks in a row, and the rest of the nodes in the network have failed to sync with this node in time. This usually doesn't happen because the node with the freshest block tries to spread the message as fast as it can, so that no other node gets there before them, right? Because if you are slow in spreading the knowledge that you've mined a new successful block, then someone can steal it from you and take the block reward. So if you're legitimate, you want to spread the gossip of a new block as soon as possible, right? So it shouldn't happen that you mine a lot of blocks in a row and the other nodes fall behind. So usually it doesn't happen. It's only an edge case where it happens. Whereas if you've got a longer reorganization, usually it's malicious, because there was a node that was offline, it was disconnected, and it mined its own chain, right? The node has intentionally split from the network. And this was with a reason, and it's most likely to double spend some coins, right? Usually long-term or deep reorganizations don't happen for legitimate reasons. And this is the basis of the ECIP 1092 proposal. I'll pass it off to Kripas from a miner perspective.
Okay, hello guys. So basically we as a miners, and I think this proposal is completely in line with what miners thinks, as I know many people that are mining and are really concerned with these 51% attacks that are happening. And from the perspective of this proposal, I think the question is, if you are offline, yeah, and this is first thing we are looking when we are looking for new places, is there a good internet connection? So the question is, if you are offline, how you are helping the network, how what you are mining actually, because mining essentially is confirming transactions. So what transactions you are confirming, like what you do. And I think the simple answer for that is you planned something bad. So from that perspective, this proposal is really simple and straightforward. It's if you are offline miner and you are proposing to sync more blocks, then most likely you don't help the network. And I will get it back to Ambroid. Your mic is off.
Thank you. So what the Perl team, the question that the Perl team asked was, how far back can a legitimate reorganization of blocks happen? And they realized that normally a deep reorganization should never happen. So this is the human speech for the code that's proposed in ECIP 1092. I'll just read this off. The longest chain is the right chain as long as it does not suggest to reorganize more than X blocks in the past. If a peer offers a longer chain then proposes to reorganize more than X blocks that a node is currently in, then that chain should be rejected and the node should remain in the current version of the chain. So what this proposes is that say there shouldn't be a reorganization deeper than 100 blocks. So what happens then is the Ethereum Classic team can contact all the exchanges and tell them that reorganizations deeper than 100 blocks will always be rejected. So you can set your confirmations for deposits and withdrawals to 100 blocks, and that will make things safe, right? So passing it off to Master Dubs.
Thank you. Okay, so we coded Fieldguard to avoid that kind of reorganization. With Fieldguard, a bit of explain, you have a threshold of reorganization. This threshold, we set it to the number we want that the transaction is definitive, so you cannot change. And it's that number that will set the penalty of the reorganization, because it's possible that two chains were offline for a moment, or a node they have some latencies between internet and to reach the other node. So we cannot just penalize the node directly. We need some kind of threshold, and that's a parameter we set in the code. So you can adjust that parameter to the confirmation of exchange or any application of third party. You don't need to have someone that manage that. And it also allows you to have some small reorganization, because that happened too, especially when you have delay. So the code is really simple to understand. You can read it. We just count the block that comes. If you are mining and if your node is sync and they see like 100 block comings, it's not normal. It's most of the time malicious. And then we take that blocks and we apply a penalty to that blocks. And so the chain is rejected by the main chain. And if the miners want to get that chain accepted, he needs to mine to decrease the penalty, because the penalty can decrease on each block. But when he mine malicious block, and when he mine malicious block, he get more penalty. So he needs to overtake the network offline first to mine his block, and then he needs to overtake the network for a long period of time online and get his chain accepted to make a 51 attack successful. That solution is already implemented in Peel and Callisto, and in 6 or 7 networks too. It's running for 2 years now, and it was developed in response of this 51 attack that we got. So implementation is really fast and easy. It's like 10 lines of code. And you can activate it and deactivate it later if you find a better solution, or if you don't like it, that's possible too. It's really plug and play, and you secure the chain. What is important now, I think, for ETC and for the whole crypto community also, because it's bad to have that kind of actor able to harm chain and harm peoples as minor investors or just users.
Okay, guys, I will also add something from simple miner's perspective. Also, I read the code, and it's pretty straightforward. It's really just few lines of code. It's nothing complicated. I think even for non-programmers, it's completely useful just to go and take a look on the code. It's really good. Also, from perspective of a miner, I think what we are looking for is quite simple and proven solution that would secure our investments, because we made investments in hardware. We want to mine Ethereum Classic, and for example, if I would choose personally to mine to Ethereum or Ethereum Classic, and this is also something that we present to our investors. We are always saying we are mining Ethereum Classic, and also look forward, Ethereum most likely will move to proof of stake in future. So Ethereum Classic is plan B, where we will be always be able to mine Ethereum Classic, and now it's a little bit hard to persuade our clients, because we have product where we are selling also mining power to clients. Is hard to persuade them to buy Ethereum Classic product because of the 51% attacks. And so that's from my perspective, I think all that I want to say to that. And last thing that I want to add is from discussions that were on GitHub, I think it's just a solution that will give us more time to develop more complex solutions from, for example, IOHK, the 1097, the checkpointing, or other solutions. But I think there are much more complex, and there is much more time needed to research and test the solutions. So that's all. And I wanted to thank all of you guys to come to the presentation, and I think we can start the questions if there are any. So first question about time proposal. I think it's rather connected to community, because there are some rules how the ECIPs are moved. So what we are hoping to achieve is to move this proposal as fast as possible to last call, and then there is a minimum 6-week period, but it's not right question here for us, because it's rather for community, if community would be able to push it forward faster. In regards of, there is a question, if attacker can mine offline and present reorganization, then double their hash power to surpass the penalty threshold to successfully complete an attack. I think it's a question on Pirol team.
No, it's yes, of course you can. It's just that it's much more expensive, right? You would need a really, really large honeypot in terms of an exchange, where you could offset the investment of doubling down on already owning over half of the hash rate in the network, right? You would need to have something like 70+% of hash rate in the network. And at that point, and you would need to double down on it, right? You would need to, it would take time. So an exchange could shut down their deposits in the meantime. They could respond to this. They would have time to see that something is wrong with the blockchain itself. And usually exchanges do already have these kind of early warning signals, but they are just not fast enough to respond typically. So this gives exchanges more time to respond as well.
Also, I want you guys to point also to the GitHub where the proposal is. When from in one of the latest tweets there are comments that I commented 8 days ago, there is a mathematics that explains the penalty. So it's basically more complex. The more blocks you have, the harder it is to basically secure the attack. So it's different story if we will talk about 5 blocks reorganization, and different story if we are talking about 5,000, because and this is in the comments, so I would just ask you to go there, because there is, I think, complete answer. If you are not satisfied, just comment there and we will get to you with a deeper answer. So
yeah, maybe we can just add as an example to that question. We make a calculation. If you make a reorg of 5 blocks, you have to mine 41 blocks. But so if you mine together and you push your block, you want to mine more blocks, you will have more penalty. So you will have to mine more. So we make a reorganization of 5 blocks. For 5 blocks, you have to mine 41 blocks in competition with the main chain. Just imagine how many blocks you have to mine if you make a reorganization of 7,000 blocks.
So to the next question, what are the drawbacks of this proposal according to the opinion compared to the current consensus? And from my minor perspective, and this is where of course I'm it's hard for me to answer from any other perspective. From my perspective, there is absolutely zero drawbacks, because that's the point where if you are miner and you are mining offline, like, is it really what was proposed from Nakamoto? It's hard to believe that the idea from the beginning was like this. I think the idea was the strongest, the longest blockchain wins, but that's still in place. So if the community doesn't or wants to split and have different ideas, so miners can show with their, let's say, powers what their belief is truth. So this is completely different than stealth attacks that are happening offline. So I don't think it actually even touches the current consensus.
There was a question, what is the history of this proposal? Did Horizon propose and adopt this first? What makes your proposal different from Horizon? Horizon implemented a solution as penalty where we get inspired, and it's where we get Pilgard off the ground. We are inspired by Horizon 2, and we make some variation in it. So, for example, we implement some penalty difference when you have low difficulty or based on the difficulty and so on.
So I would also go to question, if your solution works well, prevents 51% attack successfully, why would also later implement other, let's say, solutions? First of all, it's hard to say, and if this proposal is complete fix to 51% problems. I would say it helps us to get time to develop our own and more complex solutions, like, for example, checkpointing, and actually from the discussion it's possible to implemented simultaneously. I think it's a little deeper than just this is fixed for everything. But what we do believe is that because it's proven solution and it's tested solution and it's really simple to implement, we do believe it will just simply provide us necessary time to be able to implement more complex solutions like the checkpointing that was proposed. So there is question if you planned updating our ECIP that is not technically explained other than a few links to some code snips. I think the code is self-explanatory, and this presentation should be able to help you to understand the code, because as I said, the code is quite simple. And also the comments, if you read the comments in the section, there is a big discussion going on about Eclipse attacks or other things. So from our perspective, at least I do believe everything that should be showed or proposed is inside the GitHub ECIP 1092 page, including the comments. Yeah, the reason, what is the reason behind the multiplier calculation for difficulty? So I think it would be better if Pirol will answer for that, but you are right, in our case it would stay always 1. The multiplier will be always 1.
Well, we do that because we are a smaller chain and we wanted to increase the difficulty. Still, you can change it to adapt to your chain and what you think it will be more important, or some point that you need to multiply that penalty. So that's up to you. Also, the code is there. The code is open source. You can use it and change it also if you want. So it's there to be improved and adapted to your own utilization in chain. Like the block you consider you want for the reorganization, sorry, you have to adapt it to your chain too. There is a parameter for that. That's commented in the Git.
Yeah, also because I think we went through all questions. So one of the last things that I wanted to say also is it's extremely useful to also read the GitHub page that is from Dexaran, and that's named Amendment to Nakamoto Consensus, which is going much deeper in detail about the different versions of attacks, and is explaining philosophy around the attacks. So that's also something to consider. So if nobody has any questions, I would ask our host.
Brilliant. Thank you very much. Thank you very much, guys. Much appreciated. And I hope everybody on the call got the answers to the questions they wanted. So thanks to everybody for joining us. As Brian said at the outset of the call, we plan to have at least another couple of showcases like this next week, hopefully. So follow IOHK on Twitter, and we'll alert everybody as to when they're arranged and organised. But I'd just like to thank the guys here. So that's Kripos, Ambroid, and Master Dups for their presentation today. Thank you to everyone for listening, and we'll see you again soon. Cheers.
Thank you.
Thank you for having us. Bye-bye.
Cheers. Thank you. Bye-bye.